Hi friends, let us continue our designing activity. So before starting the actual design, some preliminary activities we need to take care. So to simplify the task, instead of taking up down floor buttons, we have assumed only one floor button for each floor. So that is F0, F1, F2, F3. So anybody from second floor wants service of the elevator will press a button in the outside the elevator at second floor, that is F2, and so on. Then once he enters, he will dictate the elevator where it should take him. So this in car switches will be used for that, C0 to C3. So the whole activity, let us assume that they begin when some of the key is pressed. So when no key is pressed, so all four inputs from floor switches will be 0. Therefore, this output will be 0. All four inputs from the in-car switches will be 0. So output will be 0. 0 or 0 will be 0. So it says that no request is come yet, neither from floor nor from the car switches. No service request is requested. If any of the keys is pressed, that's what happens when we begin our journey. So elevator will be at some place. Okay. Then somebody from outside, that's a floor switch, will be pressing. And once the floor switch is pressed, this goes high and hence request goes high. And whichever floor is pressed, one of the four inputs will be high, and which input is high, its coded version will be available. If it is F0 is high, we get 00. If F1 is high, we get 01. If F2 is high, we get 10. If F3 is high, we get 11. Same way for this also, we will have. And then we don't know which is going to be useful, whether floor switch is pressed or in car switch is pressed, we don't know. Therefore we just multiplex them and select one of the two outputs, and this selection has to be done only when somebody requested the service. So this whole system gets activated only when there is request. So this is a enable key, active low enable key, therefore request bar is given here. And which one to select, so that is given by car register. So if input is from car register, then this will be high, so we get high, means these two gets connected to output. If it's not from this, then it has to be from this, then this will be low, therefore these two get connected here. So whatever is which somebody requested from some floor, then we get from here. And somebody requested to go to some floor, so that is given here. So one of the two comes out depending on which action was done. And that, and then from the floor sensors, as we have seen, at every floor there is a sensor. So whenever the elevator reaches that point, that particular sensor goes high, other sensors will be giving a low. So we have four uh, uh, floor sensors. So FS0, FS1, FS2, FS3 for ground floor, first floor, second floor, and third floor. Again, using 4 to 2 encoder, we encode it into 2-bit coding, and we just compare these two bits with these two bits. So this is what we call the destination where the elevator should go, and this is the source where the elevator is currently. Where the elevator is currently, it is given by the sensors, and where it should go, maybe by the request from the floor or request from the in-car switches. It says where it should go. So after comparing, we get three outputs. The source is less than destination. So now source is less than destination means the elevator is at a lower point compared to where it should go. Now with this, the elevator should be pulled up. If source is equal to destination, that means wherever the elevator was supposed to go, it's already there. So you don't have to move up or down. The next action should be taken. So if source is greater than destination, that means the elevator is at a higher floor compared to where it should go. Now with this input, now we should ensure the motor turns such that the elevator moves downwards. And as the elevator moves, this keep changing. As the elevator moves, the floor inputs, floor sensor inputs keep changing, and this source also keeps changing. So if it has in the ground floor, we wanted third floor, then this is ground means 0. So S is less than D because this is 0, this is 3. So because of this, the elevator starts moving. Then it goes to first floor. Then S becomes 1, D is 3. So 1 is less than 3. Yes, it continues to move upwards. Then it goes to second floor, and second floor, third floor. Yes, it has to continue. Then finally it reaches third floor, and when the third floor sensor gives its output, this also is 3, this is also 3. In that case, S is equal to D. Now we should make sure that elevator stops and open the door, and next activity should take place. So these are the prerequisites we need to look at before defining the operations, what it should perform. Before writing the state diagram, we need some inputs like S less than D, S equal to D, S greater than D, and so on. So that's preliminary preparations we have done. And next session, let us dive into the actual state diagram for our elevator controller. But let us start with a simple one. So it a simplest possible flow let us think of, and once that is done, then we can keep on adding more and more complications to your system. First time doing, so let us simplify the actions. Now to simplify the actions, we have added all these prelims. So using these prelims, let's get into designing the elevator controller state diagram. So that's what we are going to look in our next session. So till then, take care. See you. Bye.